Now, we will tackle the lesson about LED. What is LED? LED stands for light emitting diode. It is solid-state type of wiring that doesn't contain filaments like an incandescent or halogen sources do. In fact, the way it creates light is very different from the original source of wiring. So, there's a lot of excitement about LED, but also a lot of questions.
There are three main components of LED. The first is diode, which generates the light, lens, which focuses or aims at light, and also heat sink, which drives heat away from the diode.
LED is used widely in many appliances like television, computer, and also in bulbs. In LED, you can save consumption on bills and to our environment. But did you know that LED is more efficient? Let's find out in the next video I will present to you.
LED bulbs are extremely high energy efficient. This incandescent or halogen bulb can use up to 60 watts of electricity. While if compared to a CFL or compact fluorescent lamp, this usually uses only 15 watts. But if we compare, they cannot beat LED's 7 to 8 watts of electricity. Quality LED products have an average of life up to 50,000 hours. That's 50 times longer than most incandescent lamps and 5 to 6 times longer than most of CFL. By 8 hours per day, 7 days per week, and 52 weeks per year, we can justify that it can last up to 16 years.
Now we know the great benefits that LED brought to us. But how vast our knowledge on how this diode works? Thus, the processing of these LED products such as bulbs.
LED is a basic semiconductor device. P-type semiconductor material containing positively charged carriers called proton is combined with N-type semiconductor material containing negatively charged carriers called electrons to create a diode. When a current supply is connected to a diode, the negative charged electrons are forced to move one direction, and the positive charged protons move in opposite direction. When a free electron comes near a proton, it combines with it. A proton exists in lower energy level than the free electron, so the electron must lose energy to combine with the proton. This energy is released in the form of photon, or unit of light. The amount of photon energy released determines the frequency or color of a light. The type of material and process of creating the N-type and P-type materials dictate the color of the photons as well as the efficiency and other performance characteristics of LED. After processing the material into an LED chip, the chip will be installed in a package that allows the electrical connection and directs as much light as possible in the desired direction. Producing LED starts with a substrate. The substrate is sapphire or Indian LED or gallium arsenide. Layers of various materials are grown on substrate. These layers are applied on precise pressure and temperature control. These make up N layers, active region, and P layers. This process is called epitaxial or epi-growth. The brightness, color, and intensity are determined by the quality and consistency of the epi-growth process. After the epi-growth process, individual LED chips are defined on the wafer. The wafer will examine and separate individual LEDs. The LED has been tested, where the exact color and all electrical characteristics are recorded. Finally, the LED is installed in LED package. Wire bonds create the electrical connections. A lens is attached to direct the light. In the case, silicon is added to protect the LED chip and fill the air gap between the chip and lens. And now, assembling the LED package is now complete. The last step is to test each LED and organize them according to color, brightness, and other characteristics. For some products, LED is installed in arrays. This array contains multiple LEDs installed in a PC board, designed for a specific application.